Good morning. I am Vijay Madhvi. Today we'll start with our second unit. Okay. Now, what is our first main theme in this second unit is the first unit we just learned about the physical layer. Now, here we'll learn about the data link layer. Okay. With the data link layer, here we are going to learn about this error detection and error correction fundamentals. Okay. And now here, what is meant by data link layer? See, just here we have the OSI model. In this OSI model, we have the physical layer, data link, network, transport, session, presentation, and application. This data link layer is the second layer. This is mainly used. The data link layer is a layer 2. It moves the data into and out of a physical link in a network. Okay. This is mainly used for the data transmission. Okay. And next, see here. Now we'll see what is meant by a data link layer. It is a protocol layer that handles the moving of data into and out of the physical link in a network. Okay. And it is a layer 2 in the OSI architecture, and it is useful. It is a model for a set of telecommunication protocols. Now here in the data link layer, what happens? The data is transmitted in the form of bits. Okay, here the data is transmitted in the form of bits. It means, see, the data bits are encoded, decoded, and organized in the data link layer before they are transmitted as a frame. Here, whenever we are seeing like in the transmission of data between the two systems, here the data is formed in the form of frames. Okay, and here the data is encoded as well as encoded and decoded and organized in the data link layer. Okay, and here I told this is in the form of frames. Okay, and the data link layer also determines how how devices recover from collisions, and they may occur when nodes attempt to send the frames. Okay, and here now in the data link layer, here the major functions for the data link layer are, whenever if we have this transmission, this data link layer is having mainly three functions. What are those three? It handles a problem that occur as a result of a bit transmission errors. Okay, it ensures that flows at a pace that does not overwhelm the sending and receiving devices. Okay, it permits the transmission of data to layer 3, that is the network layer. Here it permits the transmission of data to the network layer. Okay, and here this network layer is the layer 3. Okay, and next here, and where it is addressed and routed. Now here this is our OSI model, and here now we'll learn about what is meant by this error detection and this data link layer that ensures an initial connection has been set. It divides output data into data frames and handles the acknowledgement from a receiver. And it is going to check whether the data is arrived successfully or not. Okay. And it also ensures incoming data has been received successfully by analyzing the bit patterns. Okay. It is going to check whether the incoming data has been received successfully or not. Okay. By analyzing bit patterns at a specified places of the frames. Okay. And this is the one of the technique. Now here, this is how the data is transmitted from the data link layer. Now the data is in the form of frames. That means in the frame, the data is in the form of bits. Okay. Now here, this is at the sender side. This is at the receiver side. If the value of 0 is here, then if it is changed to 1, means it is called as the packet has been received. Otherwise, the frame has been received at the receiver side of the data link layer. Okay. And how the errors is going to occur in the data transmission. There may be any number of ways the error may occur. Like the errors in the data transmission can occur for a variety of reasons, such as some electromagnetic interference or some noise or some hardware issues or some any software issues. So many may occur. That means, see, the errors can lead to the what we have, what is the problem occurs, like insertion, deletion, and inversion, alteration. Any type of problem may occur at the time of transmission. Okay, and now here we have different types of errors will be there. Like whenever if we have the data transmission, the data is transmission between the sender and receiver in the form of frames. Okay, and here in the transmission, we may get some different types of errors. First, we'll see what is the first type of error, that is single bit error. A single bit error occurs when one bit in a data unit changes from 0 to 1 or from 1 to 0. For example, if the data is transmitted between the sender and the receiver. Okay, because of some noise or some interference or any other issues, the data is changed from 0 to 1 or 1 to 0. That means it is a common, but if it is detected and corrected using the error detection techniques, here these types of problems can be solved by using the error detection techniques like Hamming codes or parity checks. Okay, and the next here, like we have a send, we just send and receive. Okay, that means if there is any error, see if sent and received, but here 0 is changed to 1. Okay, due by using the parity bits or some like Hamming codes, we are going to rectify the single bit error. Okay, and next, what is mean by this burst error? Burst error involves the consecutive alteration of multiple bits within a data unit. Okay, that means see, there may be some issues with the transmission. Okay, that means the bits may change. Like not only one, in the single bit occurrence, we may have the single bit error, we have only one error will be there. But whenever if we have this burst error means multiple errors may occur. The multiple bit values may change. Okay, that means these errors can occur due to the factors like single errors, some signal attenuation, or any some signal issues, or some noise issues, or some electrical issues. Because of any of these issues, it may occur. Okay, it is called as a burst error. And the next, random error. What is mean by this random error? These are the random errors are the temporary and unpredictable changes in the data. Okay, that means if there is any change which happens in the data transmission, then we can call it as a random error. Okay, the random errors are the temporary and unpredictable changes in the data due to factors like temporary electrical interference or some cosmic rays or momentary glitches. Okay, and the other type of error is systematic error. What is mean by the systematic error? Systematic errors are also known as deterministic errors. And these are consistent and these are the repeatable errors. Okay, and that occur due to the flaws in the system or equipment. And the other type is what is meant by a noise. Noise is also one type of error. Here, like because of noise, the errors may occur. The main thing is because of noise, the error may occur. But what is that noise? This noise refers to an unwanted signal or interference that distorts the original data. Already we have some original data. That original data may distort. Okay, because of this noise. The noise can be introduced during the data transmission due to various sources like some electromagnetic interference or crosstalk or channel attenuation. Because of any of these issues, the noise may occur. Okay, and what are the different types of error detection techniques? We may have n number of error detection techniques that have been developed and standardized to safeguard the data during the transmission. Here the few prominent ones. What are the different types of error detection techniques? The first one is a parity bit. Another one is a checksum. Another one is a cyclic redundancy check. Okay. And what is mean by this? Parity bit check. Parity check means what? Here I have a sender. I have a receiver. From the sender side, I am transmitting the data. Okay. And to transmit the data with a proper address, here I am going to add some parity bit. Okay. See, the parity bits are added to data to make the total number of ones either even or odd. Okay. And thereby allowing the detection of single bit errors. Okay. But simple and easy to implement. Here, now the one is added here through the transmission media, the data is transmitted. Okay, and finally the receiver may receive the data. What is meant by this checksum? We are going to add some value to the previous data. Checksum involves a calculation of sum or some hash value from the data itself, appending it to the data being transmitted. Here, we are going to send the data from sender to receiver. And here we have to add some parity bit. If I add 1 here, then what is happening here? Here my first value is what? I'm sending 100110001. 1 second. Yeah. Here I'm sending next. Here this is a value. And what is the value of 1 and 1 or 0 means I'll get 1. 0 or 1 means I'll get 1. 0 0 means I'll get 0. And 1 0 means I'll get 1. 1 or 0, I'll get 1. 0, 1, I'll get 1. 0, 1, I'll get 1. 1, 1 means I'll get XOR value, that is the 1 and 0. Here I'll add the value 1. Then I'll get the different values. Next, finally, the checksum will get like this. This is the main theme, like it is called as a checksum for the transmission of data. Okay. And what is mean by cyclic redundancy check? The CRC means it is a widely used error detection technique that involves a polynomial division. Okay, the sender and receiver both use the same polynomial to perform the division. Okay, and if any reminder indicates the presence of errors. Okay, here the sender will do the polynomial division and the receiver will do the polynomial division. Okay, if both sender and receiver is doing the polynomial division, if they get any value is pending, then the error occurs wickets. Okay, and here what is mean by this error correction? Once what is mean by error detection? In the error detection, we are going to find whether if any error occurs. In error correction, what we'll do here, we are going to rectify those errors. Okay, to detect and correct the errors when data is transmitted from the sender into the receiver. Here we have two types of data error correction, backward error correction and forward error correction. Okay, and here in this backward error correction, once the error is discovered, the receiver requests the senders to retransmit the entire data unit. Okay, that means at the sender side only, if we get like if the error has been discovered, some error we got some error, then what the sender will do, it will retransmit the entire data unit. And what is mean by this forward error correction? And in this case, the receiver uses the error correcting code, which automatically corrects the errors. Okay. With this, we just completed with what is meant by error detection and error correction. In the next session, we'll learn about what is meant by this Hamming code. Have a good day.